I'm going to show you how to process the raw data files we extracted from the MATLAB software using MATLAB so that we get the same image and graphs that the MATLAB software produces. So to begin with, we clear our windows, our command window, to make sure we start from a fresh page. Then in our user settings, we copy the file path. So instead of bringing the raw data values into MATLAB, we tell MATLAB to read the raw data values wherever the file is located. So I'll show you how to do that. So you open where your file is located. Then you right click and you copy the path. Then you paste it right in here. Then MATLAB will be able to read the file wherever it's located on your folder. So we assign a unit to our z values, which is the z values tell us the height and the depth. Although it's already in millimeters, but it's just safety check. And also we assign a threshold to the z values, of which you can choose any value of your choice. So we choose 10 microns here. I chose 10 microns here for the processing. So it means that the threshold will delete any roughness and noise on the surface of our image. So actually it's plus and minus 10 microns. So anything below 10 microns will be counted as a whole, and anything above 10 microns will be counted as a peak. But anything between plus and 10 microns is deleted and omitted, and it's not processed as part of our it will not be used for our metric calculations. So we then load our data, which is already in X and Y. Then we put them in a vector form so that they can be processed independently. Then we also tell MATLAB to push out and show us in the command window what our X maximum is, our Z maximum is, and our Z minimum is. So with this, I use this to verify that my raw data value is correct by comparing my image here processed by the MATLAB the same to the one in MATLAB. So it will show, MATLAB will show this minimum and maximum values of the height of the topography right in this section, and now I compare it to the one I have in the MATLAB. Then because the one I have in the MATLAB also has a minimum and a maximum z value, so you can compare it and see that they are the same or not. Then we go to the grid section. So we assign X and Y, we assort them with a unique value, UX and UY. So we are finding the unique coordinate values, and we also count the number of elements in each of the unique values. Then after that we put these unique values into a grid. into a 2D form. I mean, is the same as a 2D grid, and so that it can help further process our image. Then we also find our index location. This is also to find the index location, and we also validate our unique positions, the index locations. We validate them to make sure that they are being positioned at the right point on the which will be used to create the image. And also we also validate our z-grid as well, to ensure that each of the points is existing in the grid. Okay, and we also use the pixel area, which is also very important. And we know that every pixel is a point. So now we find the spacing between the unique values by also using the average, by finding the average. Then we assign it to dx, and the same for the dy. Then we make the point an area. So the point is actually an area which consists of an x and also a y, making up a pixel area. Then we also assigned MATLAB to find the minimum z-grid and the maximum z-grid. Okay, so this will help MATLAB to further process our image by combining the z-grid positions with the pixel area in order to form a 3D image. And also the plot version, in the beginning when I processed the image, there was the image was inverted, and it looks different from the one in MATLAB. So I have to flip it here. So I flipped the z-grid so that I get the direct and exact resemblance in the one in the MATLAB. Then the max will help us to identify which part is the hole and which part is the peak. So anything above the z minus, which is our z minus threshold, is a peak, is a hole, and anything below it, our z threshold, anything above our z threshold becomes our peak. So actually, just like in the beginning I told you about the threshold, that is what it's doing here. So plus and minus 10 microns, anything above it, the 10 microns is a peak, and anything which is below our 10 microns becomes a hole. So that's basically what the max is doing here. And the metrics, so we are counting the number of pixels that are holes and the number of pixels that are peaks. So we assign them n holes and peak. Then we bring them here to also calculate the area. So we combine the n holes, multiply it with the pixel area. So then we get the area of holes. Then we combine the n peak and we get times the pixel area, then we get the area of the peaks. Okay, so actually we have been able to determine the area of the hole and also the area of the peak as well. Then we calculate the volume of the peaks and the hole also. So it's a summation, which is also an integration of our the z grade, which is a hole, times the pixel area. So this code is to omit um, any non-applicable values. I checked the raw data values and there's nothing like none here in the raw data values, but for safety check we also put to omit any non values which might be in the data. And the absolute value here is supposed to give my holes a positive value, because on the raw data the negative values are assigned to the holes. So putting an absolute values here, make sure that our metric value or our calculated value will come out as positive and not negative. So for the peaks, the peaks are positive, so there's no need to assign an absolute value to it. So the same as the volume for the peaks, the z grade, which is for the peak, which we have identified earlier, multiplied by the pixels. Then we calculate the volume for the peak as well. Then also um, we determine the deepest height and um, the maximum height and the deepest point of our raw data value. So just like I said, always the depth are always negative. So putting an absolute values make sure that our calculated value comes out positive. Okay. Then we also display the result in our command window. So this code help us to display the results which has been calculated, our metric results, the whole area, peak area, whole volume, peak volume, maximum depth, and the maximum height. Then we go to the graphs, the images which will be also be projected or will be produced from the MATLAB. So I have assigned the values to the this is actually will produce the 2D image with a legend showing the color map, which I have signed here, and with the axis which has been set and the viewing style and all that. So I've also assigned the title to it and the X and Y label to it, and the marks will tell us which part on the surface of our image becomes a hole and which becomes the peak. So I've also assigned a color bar, and the background, the hole and the peaks to it. The background is actually the noise on the surface or the threshold which has been omitted from the surface of the image, and it was not part of the calculation. So it will tell us which part is the hole and which part is the peak. I've assigned the color maps to it, and also the 3D, which will show us the 3D view of our processed image, and also the same I've assigned color maps to it, showing the telling the MATLAB to show me the maximum on the topography height and the maximum on the maximum of the minimum and the maximum of the height on the image, and other other units also I've assigned them on the graph, 3D graph that will be projected, the viewing angle, the title, and the label as well. So you go ahead to run it in MATLAB and see the result MATLAB will give us. Yeah, so MATLAB has given us the calculated values and also the images. Okay, so let's look at the calculated values. So just as I showed you in the beginning, to print out these metric values, and which are very important for us. So we have the calculated result here, or has been projected by MATLAB, and the unit as well. So looking at the 3D, which is this side, it looks exactly like our image in the Leica map, and we can tell and see the peaks and also the hole on the 3D. So you can see that every point is a raw data value, a pixel value, making up, which is x, y, and z, which makes up our 3D image. You can see also here as well, this point on the surface consists of x, y, z data. And the 2D also has been shown with the color map legend, which shows telling us through the colors which is the peak and which is the hole, and also on the surface, which are mostly represented by the yellow color, showing that is the reference plane at 0. So also the marks tell us which is our background. As I have explained before, the background is the threshold plus or minus 10 microns we applied, and is identified as black. So it's not part of the calculation. That is to tell us that, and the blue region is the holes, and the yellow color is the peak. So we have, just as we have assigned to MATLAB to consider images which are above our 10 microns as peaks, and also below our 10 microns as holes. So it has detected this on the surface of our processed image. So then, just like I said, you can assign the correct or how you wish to process your or calculate your volume and area based on the threshold you are assigned to it. So we can perfectly see the color difference, the blue being the hole, the peaks being the yellow region, and also there are some blacks which are the background, which were not part of the calculation, and they are omitted from the surface calculation.